So as we go here, all right, we got our.
Is he from different or something?
It's gonna be slightly different. So let me just punch it in there. That first one. Okay, it's exponential. So four,
I'm
4 to the 5 halves power. And as Tristan did said, we got a 32 off of that. Okay. And then what do we have? You can, yeah, but you don't really need it because in just a moment, your calculator's gonna be kind of useless. So 100 to the what? 3 halves, and what do we get? 1,000. And the thing is about this one is I ask you really not to use your calculators here. Ideally, we're able to see some type of pattern happening off of this. But the problem with this is these numbers jump up very quickly. And the reason why these numbers are jumping off very quickly is because this numerator here today. And the thing that's also compounding the situation is that these numbers are jumping up so quickly, and it's just that our number sense after a while is just not. It's just hard to do in our heads. So as I keep punching these in, and we're getting these answers here, maybe a couple of these you can do in your heads as you're seeing maybe how I'm getting again a few of these numbers, and it's just maybe as we're working through it, maybe not as easy to see. Okay, what's a pattern going on here? So as I do this last one, we get a 16. And in the perfect world, we're able to see what is going on with that. And let me kind of rewrite a few of these. Now let's go back to what we said yesterday. What happened to that denominator? When we wrote this as a radical, what did that denominator represent? When we wrote this as the radical, the denominator represent the, what do we call that? We call that the what? The radicand, the coefficient, or the index?
The index.
We call that the index.
And then the numerator is the coefficient.
It's not going to be the coefficient thing. You would think so, but it's not going to be the coefficient. So we'll talk about that here in just a second, Tristan. So ignore that 5 for a moment, okay? So the base of 4 is my radicand, we say. That index is my, is that 2 there from that denominator. And what's the square root of 4? The square root of 4 is 2, right? And now that 5, what's happening to that 5 is that 5 is actually going to stay right up there as the power.
And what's the coefficient?
There is, I'll talk about it in a second. Give me a second there, Tristan. And what is then, and this is where our number sense is coming into play. If I now type in 2 to the 5th, what do you think 2 to the 5th gives me? It gives me that 32. 2 times 2 times 2 times 2 times 2. Now, as I go back over here, you just told me the 2 becomes the index, and 100 becomes my radicand. And what's the square root of 100, people? The square root of 100 is
50. No, wait, not 50.
It's not 50. 10, right. And what is 10 to the third give you?
30.
Ooh, 10 times 10 times 10.
That's 1,000.
It is 1,000. So what that means is that 3, that numerator that we have now today, is going up there to that, staying up there in that power. Okay. Let's go down here to this bottom one. The 27 is my radicand. The 3 is my index. Now, this is a cubed root. And we did this one yesterday in our notes. What number times itself 3 times give me 27? And we found it out to be, you may not remember it. Bless you. It gives me a 3. And what is 3 to the second?
9.
That's where I'm getting 9. Now this is what I was trying to help you guys to see, but it's hard to do with some of these larger numbers. Bless you. So here's what's going on today. Well, now that we have that numerator showing up there, what's happening is this right here. This is what's happening on all of these. The denominator becomes the index. Nothing changed. We did the exact same thing. But that numerator now stays up there in the power. Okay? So that's what we're going to do today is rewrite these in radical form, just like we did yesterday. Denominator becomes the index. The base is my what? Radicand. And my numerator is the stays in the power. That's it. Okay? Who cares? It's a variable. Let's go from what we did yesterday. So, on that first one there, x to the, what does it say? 5 halves? Right, Destiny? So x to the 5 halves becomes, let's rewrite it. What's my index?
What is it, a 5 half?
Oh, sorry, it's a 3. My bad. I thought it was a 5 when I was walking over to bother her. Okay? I blame that on Trustney. So, there is my square root of x. Do I need to put an index? Do I need to put that 2 there?
Nope.
No. It's understood that's my square root symbol. All right? So I don't need to put a 2 there. But what I am looking for now to have is, why do I keep putting a 5? Trustney, I blame you. I leave that 3 up there in that numerator. Okay? Yeah. I like to see those parentheses there. Yep, get over yourself. Get over yourself. Okay. That's it. Okay? We're rewriting this from what? Exponential form to radical form today. Back and forth like we did yesterday. How about the next one? What's that going to look like? Square root of y to the what power?
Numerator is 5.
To the power of 5. Now, what's my next one going to be? My index is what? 3. So make sure you have a little 3 there. Don't make that 3 too big so that it looks like a coefficient. That's not what we have. Make sure you make that a 3 such that it looks like a index. And it's a x, not a y. And what is my power?
5.
That's it. Z, what's my index?
7.
So make sure you have an index of 7 to the what power? Numerator stays up there at a 4. Okay? You good, Ari? That's a Z. Yep, that's a Z. Usually I write all of Z. A lot of times you see Z's like that, so they don't get confused with like 2's or anything like that in math. And then A to the 2/5 becomes what? Index of 5. Radicand is 8. All to the what power? Second power. Now on this next one, I threw a little bit of a curveball to you. This is what we did yesterday, wasn't it?
Yep, just the
What
index
number is
is
it?
3.
5?
That's a 5 because the denominator is what?
Okay.
5.
The index is 3, and then the x is the
Radicand.
and that's all you do.
Yeah, do I need to put a parentheses and 1 up there? No.
No, it's just
Correct. So this is what we did yesterday. I could have done yesterday with you guys and then put all those in parentheses to the first power, but do we need to put all those to the first power like that? Correct. I did not need to do that. So I'm going to erase that out of there, and this is what we just did yesterday. So what's that next group going to look like? 4 to the 2/5 is an index of 5, radicand of 4 to the what?
second.
5, so 3/4 is a what? Index of 4 to the third. Now, when we get to our next quiz on this, some of these are going to become multiple choice. Now, at the beginning of this lesson here, Tristan thought he knew what was going on here, and I'm not picking on Tristan or anything, but he did do a typical mistake that I expect to see. And I'm going to have some of these as multiple choice. He thought that 4 went out front to become a coefficient. And don't fall into that trap, all right? Because that is a mistake that I totally expect to happen. So that 4 is not the coefficient, is it? That 4 is representing what? It is representing the power. It stays up there in the exponent. And again, I don't need to put that 2 there because it's understood this is the square root, our common one. Boom, we're good to go. Now reverse all that for me. I give you the radical, write it as a rational exponent. Rational exponent means show me those fractional exponents, okay? So on number 3, what's that going to look like? Look like we did up top there. What's the next one going to be? The radicand of 5 becomes my what? Becomes my base. And what's that going to look like? 3 over 4 or 4 over 3? 3 over 4, right? Look what we did up top. Follow what you did up top. And just reverse it, right? That's it. And we just did that yesterday, didn't we? Except all those yesterday were, excuse me, what? Like 1 over 2, 1 over 3, 1 over 4. Now it's just going to be 3 over 4, 3 over 5, something like that. And what's the next one going to look like? X to the what?
4 over 5.
4 over 5. What's the next one going to be?
2 to the 7 over 3.
Radican becomes the base, and 7 over 3. That is correct. It doesn't get any much crazier than that, guys. We did the hard work yesterday to make hopefully today not too bad. 7 to the what?
5 over 2.
5 over 2.
6 to 3 over 2.
There you go. I don't see an index there, so what's always hiding there? Now, I'm going to make a silly mistake here. Those are the silly mistakes that I expect. All right, and why do we think those? Because most of everything that we've done throughout your math careers, we say if you don't see something there, what's usually hiding there? Usually a 1. But this is our exception to that rule. Okay, as we've been saying, that's the square root symbol. And in this instance, that means a 2 is hiding there. That's correct. The index is 2. And what about the last one?
Y 3 over 2.
Thank you, sir.
What if it was 1?
There is not a radical that has a 1 there. It is a 2 is the lowest index. Okay. What that's getting into is with radicals, you're always looking for the radical like that, the square root of like 4. You're always looking for something that makes a group of something. So an index is looking for a 2, is looking for a pair, a group of 2. Here, if it's a cube root, you're looking for something that makes, for 27, 3 times 3 times 3, you're looking for a group of 3.
So if it was 1, it would just be.
You're not, yeah, and you're not going to have a radical of 1. So we don't get into that. It's just radicals of 2 or higher. Okay. In algebra 2, when you get to that in a couple of years, that's where you'll get into more 4th roots, 5th roots. We're laying the groundwork for you right now, Tristan. In geometry next year, you're going to get into more these and 3rd roots. And then algebra 2, you're going to get more into the higher roots. Not quite there yet, are you? Okay, last group here. Now we have some coefficients out front. Now this is where you got to be careful. This has got to be careful where how far does that radical go? How far does that radical go? So on letter A, how far does that radical go? Does it go all the way out to that 5, or does it only go out to the x? So does it go all the way out to that 5, or does it only go out to the x? What's your thoughts? All the way out to the 5, or does it go only through the x? Just to the x, because what does the 5 have with it? It's got a 2, so what is that? The 5 is by itself. So that 5 squared, that's my coefficient. Now, treat the x to the 5/3 as by itself. So now take the x to the 5/3 and do what we've been doing, okay? Rewrite that into radical form now. What's x to the 5/3 going to become? What's my index on that? My index is what?
X.
Index is what?
Oh, that's
3. And I got you. And my radicand is x, and what's my power?
5.
5. Okay? So only the x is getting to that 5th power like that. The 5 is not. All right? Those are where the mistakes are going to happen. Be careful on that because it's only focusing on the x right there. Because only the x has got the 5/3 on it. The 5 has got its own separate dude. It's got a squared on it. Okay? How about the next one then? Keeping that in mind. Is the 7 going to get the parentheses like that with the radical on it?
Nope.
No. The 7's by itself. So it's going to be 7 squared. And then what's my index? 5. Radicand is y. And what's my power?
3.
Correct. Now, if you give me those answers, that is great. I will definitely take them. What is 5 squared? 5 squared multiplies out to be what?
25.
If you rewrote that as 25 instead of 5 squared, we would take that as well. That's okay. Either one is great. What's 7 squared?
49.
If you rewrote that as 49, that's great. I would take either one just as good. Just don't tell me 14. Don't tell me 10. That's not 5 squared. That's not 7 squared. That's not right. All right. Now, how about this next one? I don't see an exponent on there. So is that going to extend out to the 7 and include the 7 or not?
Include the 7.
There's the 7. The 7's got an exponent. It's got a 1. So, just like we've been doing, the x is still kind of got its own dude going on that. So what's that going to be? Index of what?
3.
And power of
5.
So it's the same deal we were doing. So I was trying to lead you to that. 7's got an exponent of its own. It's got a 1, right? So how about then letter D? Does the 3 have an exponent of its own, or is it going to include that 3 halves?
It has an exponent of 1.
Correct. So that radical does not stretch over to that 3. It's only going to stop at the Z. And what is the index for that radical?
Two.
Index is 2 to the what?
3.
Third power. And do I need to put a index? Do I need to put that 2 there? No. How about the next one? I can clearly see a 6 squared there. So 6 squared is fine. And what's my index on that one?
5. And there's no power.
I don't need to put a power there. Why don't I need to put a power there, Tristan?
Because it's only 1.
It's only a 1. Now, if I put a 1 there, because that's kind of the habit I've been doing today, is it wrong?
No.
No. But SAT is not going to do that for you. I'm not going to have it written like that on the quizzes. I'm going to have it cleaned up like that too. And 6 squared is great, but how else can we also write that? Correct. That's probably the cleaned up version of that we'll probably have. If you give me 6 squared, that's fine too. So how about that next one? Is that going to stretch to the 5? No, because 5 to the first. And with that, it's going to be only to the x. And what's my index on the x? It is a 3.
And no power.
And no power, because it's the first power, right? Okay, that looks good. Now, what's happening on the last group?
And you do include it.
Why am I including it?
Because it's in parentheses.
So that I do have a reason to my madness with you guys. I'm not just torturing you to torture you. All right? It's that emphasis of parentheses now. So Tristan, I think, did see that difference here is I have parentheses around it. So he said I do stretch it to include that 3z underneath of that radical this time. So those parentheses play a big important role on that. Hopefully you're seeing that difference now. So what is my radicand on letter G now? Is it just Z? What's my radicand? 3Z, right?
Oh, sorry, yeah.
You're good, Emily. I got you. I knew what you meant. So my radicand this time is both of those, 3Z. And what is my index?
2.
2. And what's my power?
3.
There you go. I got you the exact same thing on D and G to see the difference there. I'm hoping you're seeing the difference. I can't do anything more there to tell you the difference between, hey, there's my parentheses and not my parentheses. I put a 3 out front. I put the 3 underneath. It's all because of there's parentheses there or not. All right, same thing on the next one. On the next one, I can see 6a is in parentheses this time. So it's going to be all of that underneath the radical, isn't it? My radicand is what? 6a.
And then the index is 5.
Index is 5. Do I have a power there besides 1?
Nope.
No. If you put a parentheses 1 there, it's not wrong. And then the last one, what's my radicand?
25x.
And my index is,
3.
do I have a power this time?
2.
That sounds pretty good. And that's as crazy as we're going to get with these. Like, if you can do these, you're situated pretty nicely then. Okay? All right, let's pause. Let me get out the, go punch that into Desmos here. All right. Excuse me. Give me a second to scroll that over. All right. It's going to always return you a, well, if it does, it's going to return you a decimal. You better use those parentheses. And then a couple things I noticed based off of some answers. Some of you are not putting in the negative exponent. And in this instance, we should be getting a negative 0.04, which is negative 1 over 25. So you should be choosing option C. My graphing calculator people, negative parentheses, negative 5 to the what? Negative 2. And the place that we've been living is math, option 1. And I promise you, you get that same result. So you fixed a couple questions that are calculator questions, like some of your guys' grades will tick up very quickly. There's no partial credit I can give back to you on that. As I scrolled through your guys' questions where you had to type it in, there's a few things I could give you some partial credit back on. But multiple choice is right or wrong. I can't give any partial credit. Those are easy rack 'em up problems. Just like you did with absolute values a few weeks ago, these are your easy rack 'em up problems. Okay. Now, the ones right below that, the geometry ones, I'm not assessing you guys on those yet. Those will be next year in geometry. Let's talk about number 8 right there in front of you. I think Chloe yesterday had a bit of a fit, I think, because she's like, I hate geometry. I don't think she said hate, but
It's the worst.
whatever. Okay, so here is our formula to calculate the area of a square. The area of a square is given by this formula. What we say is side times side, side squared. Who cares? We use this formula. The side of a square is 7x cubed. So what we're doing is using that particular formula. And what it does then is brings in our properties that we just assessed on. So I heard a 49 right there, which is correct. What we're doing is using our power rule. I don't see a power, or I don't see an exponent here. I put a 1. And this is where we multiply our exponents. 7 to the 1 times 2.
Which is 7 times 2.
And 3 times 2. Right. So the answer I'm looking for is 7 to the second, x to the 6. As Tristan said, that answer is great, or you can say 49. Either answer is correct. I would take either answer there. But it's our power rule that's happening. That formula, burn it into your heads. You're going to use that a crap ton next year. And now, it also says find me the perimeter. Perimeter means you walk it around. You walk around the sides. In the years that I've been teaching, stuff that I get to talk to you about, 90% of stuff you will never use. I totally get that. But every once in a while, I get to talk about stuff you do get to use. And that's usually in geometry. Perimeter and area and volume is stuff that you get to actually use outside of school. Now, perimeter of a rectangle, or sorry, a square here, you walk it around, you add up the sides. Perimeter is a very useful thing outside of school. Anybody plan on wanting to own a house or anything? I would imagine eventually so. Anybody looking to do some type of work in terms of architecture, engineering, construction, interior design, or like I said, owning a house, you're going to do some basics with perimeter and area and volume. Trust me, you will. I just got done doing volume and perimeter and area with my wife on working in our yards with gardens and constructions around the house. The basics. So, walk it around. These are just adding up like terms, people. What's 7 plus 7 plus 7 plus 7? 28. Now, x third, x third, x third, x third. X to the, keep it the same, okay? It stays as x to the third. You just did all that work with adding up equations through second semester. When we combine like terms, x plus x, you kept it as x. You said 2x. 3x plus 4x is 7x. X to the third plus x to the third stays as, adding up like terms, keeps the variable, you do the coefficients. Last one, rectangle is the same flipping idea as a square, except our formula changes ever so slightly. We say for the area, base times height. So, don't ask me where am I ever going to use it, because I will tell you straight up, Most of the stuff we talk about, probably not gonna happen, depends on the career you go into, always does. But there's definitely some times where everybody's gonna try to own a house at some point. You wanna end up using some of that stuff. Almost. 8, this is our product roll. And this is where we add the exponents and say 8x second, correct. Okay? So now we're going to walk around the rectangle and we're going to add up all 4 sides. So we got our calculator, we got our head. 4 plus 2 is 6, plus another 4 plus 2, 6 plus 6 is 12. And we're just adding up the same x's over and over and over, and they stay the same. And as Chloe, you said, it stays as 12x. That is correct. Okay. So, a lot of work to do, and the reason why you guys are probably not strong with geometry is in elementary, middle school, you've done not a lot with geometry. And when you get into geometry next year, it's a rude awakening for most everybody. You've got a lot of holes in geometry. All right, so finish that up.